the skills practice page for section 2.1, real numbers and number lines. We've done problems like this before. Write a real number with 5 digits to the right of the decimal point. So we'll just do a couple together. If you need more help on some specific ones, don't be afraid to ask. Number 2 says a rational number between -2 and -3 with a 2-digit repeating pattern. Again, you could look at the number line down here to help you. In between -2 and -3, you start with -2, point something. Now, a 2-digit repeating pattern automatically makes it rational. Just pick whichever 2 digits you want. Okay, so I chose 363636. I know that's 6 digits, but 2-digit repeating pattern. Number 5, a rational number greater than 15 but less than 20. How are you going to make it rational? Well, you could just leave it like that. 17 is greater than 15 and also less than 20, and it's rational because you can write it as a fraction. Now, if you wanted to put a decimal on, you could. You could put a decimal on that goes on forever, as long as there's a pattern. Or you could just pick a decimal that terminates, like that. And you could pick as many as you want, as long as the decimal stops. It doesn't have the ... It's automatically rational. So I could do this if I wanted to. That's a rational number because I don't have a ... I know what comes next. It's a bunch of zeros. Number 7, an irrational number less than -5. So less than -5. Here's -5 on your number line. Less than that would obviously be on this side of it. So maybe something like -10 point something. What is going to make it irrational? You need a non-terminating decimal with no pattern. And again, I know it said 5 digits, but I got a little carried away and I just listed a whole bunch of digits. But there's no pattern there, and it goes on forever. Okay, next section gives you a number line. Again, it's good to know the scale. We're not counting by ones. There's a little unit in between here. We're actually counting by halves. So if you're a counting person, be careful. We'll do number 15 together. We want the distance from point B to point X. I know that point X lives at 5, and I know that point B lives in between 2 and 3. We need to subtract those. Remember, distances and measures are always positive. That's why the absolute value is there. If you wanted to count, you could. 1, 2, and then a half. Let's look at number 18, distance from point L to point Q. Point L lives at -5. Point Q lives in between -2 and -1. Be careful there. That's -1.5. You need to subtract. You're finding the difference between those two coordinates. Okay, so some of us might struggle with that. If you do, just use your calculator. I want -5 minus -1.5. Now look at your answer. Does that make sense? L to Z. I'm sorry, L to Q. It's not a big, huge, long segment, and that's not a huge number, so it seems okay. 1, 2, 3 and a half. Let's do one more. Number 20, we want the distance from A to X. A is in between -4 and -3. x lives at 5. Subtract them. Take the absolute value. If you're not sure, type it in your calculator. Put that 0.5 on there. And you can count if you want to find your answer. Again, that's a lot to count if you're counting by halves. So this is why subtracting is probably a little bit easier. Okay, last section, definitely a good one to look at. Consider these numbers. How are they alike? How are they different? Which one's bigger? How would you read each number? Well, this guy right here, this 0.27, doesn't have anything after it. It really does have some digits after it, and you could put as many zeros as you want. 0.27 with a line over the 7, that means 0.2 with a whole bunch of 7s, as many as you want to put, and then lots more. In this one, the 27 is repeating. So maybe I'll just write it up here because I'm kind of out of room. So just put a bunch of 27s. Okay, now that you have it written out kind of in an expanded form, this is how you would read them. This would be 27 hundredths repeating. You could say it like that. This one is just 27 hundredths. And this would be maybe 0.2 with a 7 repeating. You could say it like that. How are these numbers alike? Well, they all start with a 0.2. They actually all start with a 0.27. That 0.27 is 27 hundredths. So that's what they have alike. Now the thing that is not alike would be their thousandths digit. How are they different? So that's how they're different. Look at that thousandths digit. We have a 2, a 0, and a 7. Which number is the greatest? Well, we know the hundredths digits are all the same, so which has the biggest thousandths digit? It would be this guy. So it would be the 0.27, where only the 7 repeats.